On October 5, 2025, President Trump landed on the aircraft carrier the USS George H.W. Bush in the Atlantic Sea to witness why it's better to not mess with the U.S. Navy. Most presidents learn about carrier strike group capabilities from slides and briefings. Trump watched them shoot. And it started the way any real engagement would, with a threat appearing over the horizon and a destroyer deciding to do something about it. The Navy's response starts inside one of those 96 vertical launch cells you see here. The hatch blows open and a Standard Missile-2 rides a column of fire out of the vertical launch system. Half a second later, another cell opens. Across the formation, a second destroyer joins in. And within seconds, multiple missiles are climbing into the Atlantic sky. This is what an Aegis weapon system looks like when it wakes up angry. But the scariest thing right now for the enemy isn't those missiles, it's this radar. The octagonal panels bolted on the destroyer's superstructure you see here don't look particularly impressive. Flat faces angled in different directions, no moving parts visible. But those panels are the Spy 1D radar, and they're the reason this engagement was over before it started. Traditional radar rotates. It sweeps a beam around in circles, updating target positions once per revolution. Spy doesn't rotate. It doesn't need to. 4 fixed-phase arrays stare in every direction simultaneously, electronically steering thousands of beams per second. The system updates target track 16 times faster than conventional radar, fast enough to watch a missile's flight path evolve in real time, fast enough to calculate exactly where that missile will be 4 minutes from now. This is how the destroyers saw the incoming threat before it finished climbing out of its launcher. The Combat Information Center, a dark room packed with screens and operators, had already classified it as hostile, calculated an intercept geometry, and assigned weapons from the VLS. The whole process took 11 seconds. The threat missile had been flying for 12. But launching the SM-2 is the easy part. What separates America from the rest of the world is a conversation happening between the ship and its missile while traveling at 3 times the speed of sound. The moment that SM-2 cleared the deck, Spy established a data uplink. The radar knows where the threat is. It knows where its own missile is. Every half second, the fire control system computes updated intercept coordinates and transmits course corrections directly to the SM-2's guidance unit. The missile doesn't need to see the target yet. It doesn't need to make decisions. It just follows commands, adjusting its trajectory in tiny increments, closing the distance faster than a rifle bullet. This is called semi-active homing, and it turns the SM-2 into a puppet on an electronic string. The ship sees all, the ship knows all, and the missile does exactly what it's told. As the intercept approaches, something else happens. Mounted on the destroyers are the SPG-62 illuminators, smaller dishes that can focus a continuous wave of radar energy into a single target. One of these slews towards the incoming threat and lights it up like a flashlight in a dark room. The SM-2 Seekerhead, passive until now, just listening for commands, suddenly sees the target glowing against the sky. This is terminal homing. The missile no longer needs the ship to tell it where to go. It can see for itself. The final corrections happen in fractions of a second, tiny adjustments that walk the impact point onto the target with surgical precision. When the proximity fuse triggers, the SM-2's blast fragmentation warhead detonates meters away from the threat, shredding it with a cloud of tungsten fragments traveling at thousands of feet per second. The incoming missile doesn't explode, it simply stops existing, torn apart by physics and scattered across the Atlantic. But here's the thing about what just happened. None of it was random. The destroyer didn't fire one SM-2, it fired 3. This is the shoot, look, shoot doctrine applied to high-value threats. Against something slow and predictable, a single missile might be enough. Launch, confirm the intercept, move to the next target. But when the carrier is at stake, the Navy doesn't gamble. The first SM-2 is the primary intercept. The second is insurance against a malfunction or a miss. But missiles only solve part of the problem. They're expensive, about $2 million per round. They're finite. Those 96 cells run dry eventually, and they're designed for threats at range, the kind that show up as blips on a radar screen dozens of miles away. What happens when it's not a missile but an aircraft? Something that can maneuver, shoot back, and might be carrying weapons the SM-2 was never designed to hit. That's when the carrier starts emptying its flight deck, and that's when things get really unfair. The catapult officer drops to one knee and points down the deck. 2 seconds later, an FA-18 Super Hornet goes from 0 to 165 miles per hour. The holdback bar releases. The jet blast deflector glows orange from heat exhaust, and 44,000 pounds of thrust shoves the aircraft off the bow into the Atlantic sky. The whole evolution takes less time than liking this video. But a catapult shot isn't just about raw power. It's about precision tolerances that would make Rolexes look like carnival game toys. The steam catapult on a Nimitz-class carrier generates enough force to throw a pickup truck 3 miles. That force has to be calibrated for each aircraft based on weight, wind speed, and air density. Too much steam pressure and the nose gear collapses. The jet cartwheels into the ocean. Too little, and the aircraft doesn't reach flying speed. Same result, different angle. The catapult officer and the integrated catapult control system calculate this for every single launch. Get it wrong once, and a $70 million aircraft becomes a pool toy and a Navy Times headline. But those jets aren't flying blind once they leave the deck. They have help from something that's been circling overhead since before the president's helicopter even touched down. The E-2D Hawkeye looks like a flying radar dish strapped to a turboprop, because that is essentially what it is. The aircraft itself isn't fast. It isn't stealthy. It can't dogfight. What it can do is see everything within 350 nautical miles and process that information faster than any human brain could manage. The radar dome on top, 24 feet in diameter, rotating at 6 revolutions per minute, contains an ANAPY-9. This is the most advanced airborne early warning radar in the world, and calling it a radar undersells what it actually does. The system tracks air contacts, surface contacts, and cruise missiles simultaneously. It filters out sea clutter, weather interference, and electronic jamming. It identifies threats, prioritizes them, and feeds targeting data directly to every ship and aircraft in the strike group. And this creates a problem for anyone trying to approach the carrier. The Super Hornets pushed out 50 miles from the ship, flying combat air patrol. At this range, they're not defending the carrier. They're establishing a perimeter so far out that the fight is over before it starts. The Hawkeye feeds the targeting data. The pilots don't need to search for threats with their own radar. They already know exactly where every hostile aircraft is, what altitude it's flying, and what vector it's taking. The only decision left is which weapon to use. During the demonstration, the Hornets also performed high-speed passes over the formation. Full afterburner, a few hundred feet off the water, close enough to rattle the coffee cups in the carrier's wardroom. This isn't showing off, though it absolutely is that too. It's a demonstration of what those aircraft can do to surface targets when missiles aren't the answer. The same jet that just splashed a fighter at 100 miles can roll in with a JDAM and put 2,000 pounds of explosive through a specific window. Or it can drop to the deck and strafe with the M61 Vulcan, a 20mm cannon that fires 6,000 rounds per minute. The Super Hornet does air superiority. It does strike. It does close air support. The airframe doesn't care about mission categories. Point it at a problem and the problem goes away. But air wings have limitations. Pilots get tired. Aircraft need maintenance. Planes can only carry so much fuel. Eventually, something might leak through. That's when the geometry changes. The fight stops being about missiles and airplanes and starts being about guns, the kind that have been sinking ships since the age of sail. Only now they're radar-guided, computer-controlled, and capable of putting steel on target at ranges that would have seemed like witchcraft to Davy Jones and Captain Sparrow. During the demonstration, one of the destroyers opened fire while steaming past the carrier. The muzzle flash lit up the forward deck. Smoke rolled back over the superstructure. Somewhere on the horizon, the ocean erupted. This is what surface warfare looks like when missiles aren't the answer. The Mark 45 Mod 4 5-inch main gun fires 20 rounds per minute. Not particularly fast by modern standards, but each of those rounds carries the kinetic energy of a small car hitting a wall at highway speed. The shells themselves come in several flavors: high explosive for soft targets, extended range guided munitions for precision work, even naval gunfire support rounds designed to turn beach fortifications into gravel. The gun doesn't care what it's shooting at. But accuracy at 13 miles requires more than just pointing the barrel in the right direction. The fire control system, tied into the same spy radar that guides the SM-2s, calculates target bearing, range, speed, and heading. Then it factors in wind direction, air temperature, humidity, the Coriolis effect from the Earth's rotation, and the ship's own movement through the water. Each variable shifts the impact point. Get the math wrong and a 70-pound shell lands in empty ocean. Get it right and the target stops being a ship and starts being an artificial reef. But 13 miles is still a long way out. Plenty of time for a fast boat to close distance. Plenty of time for something small and maneuverable to slip through the engagement envelope. That's where the 25mm comes in. The Mark 38 Mod 2 sits on a gyro-stabilized mount about halfway down the ship's length on each side. The gun is an M242 Bushmaster chain gun, the same weapon that gives the Bradley fighting vehicle its teeth. Rate of fire is 180 rounds per minute. Effective range is roughly 2 miles. The rounds are designed to punch through light armor, the kind found on fast attack craft, rigid-hold inflatable boats, or anything else stupid enough to get in within visual range of a destroyer. The stabilization system is what makes it lethal. The ship pitches and rolls. The waves never stop moving, but the gun stays locked on target, compensating for every motion in real time. A human gunner using optical sights would struggle to hit anything in rough seas. The Mark 38's electro-optical sensor suite doesn't struggle. It sees in infrared and daylight. It tracks automatically. It puts rounds exactly where the operator wants them, regardless of what the ocean is doing underneath. During the demonstration, the second destroyer engaged surface targets with both its 5-inch gun and 25mm simultaneously. The 5-inch worked the distant targets. The 25mm shredded anything closer. And still, the defensive perimeter continues to shrink. Inside a mile, conventional gunnery starts running into problems. Targets move too fast. Engagement windows shrink to seconds. Human reaction time becomes the limiting factor. At this range, the Navy doesn't trust humans to make the shot. It trusts a machine that thinks faster than any brain ever could. The Phalanx CIWS, close-in weapon system, looks more like a weaponized R2-D2 than a naval gun. But don't let looks deceive you. Inside that cylinder is a 20mm M61 Vulcan cannon capable of 4,500 rounds per minute. The system can be fully autonomous. It carries its own search radar, tracking radar, and fire control computer. It identifies incoming threats, calculates intercept solutions, and opens fire, all without waiting for human permission. The engagement cycle from detection to trigger pull takes less time than a human heartbeat. The ammunition you see it firing now are tungsten penetrator rounds, each one dense enough to punch through armor plate. At 4,500 rounds per minute, the gun isn't firing bullets so much as projecting a solid stream of metal. The engagement envelope is measured in hundreds of yards. Inside that envelope, nothing makes it through. The CIWS doesn't just shoot targets, it erases them. During the demonstration, both destroyers fired their CIWS mounts in surface mode. The sound is distinctive, a mechanical buzzsaw roar that doesn't register as gunfire at all. The radar dome on top spins continuously, searching for targets. When it finds one, the barrel snaps to alignment and the buzz begins. But all of this assumes the threat is obvious: a warship, a missile, something that shows up on radar with hostile intent written all over it. But what about the threat that doesn't look like a threat? The fishing boat that went dark 3 hours ago. The cargo vessel with an unknown manifest drifting toward the formation. The small craft that might be carrying explosives, or refugees, or both. The Navy just can't sink everything suspicious. Sometimes it requires boots on deck. And sometimes that means sending in the most capable boarding force the military has ever produced. The MH-60 Seahawks come in fast and low, nose slightly down, door gunner visible in the open cabin. Behind it, a second helicopter follows the same approach path. On the deck of the simulated vessel next to the carrier, someone is about to have a very bad day. VBSS, Visit, Board, Search, and Seizure, is one of those military acronyms that sounds bureaucratic until you see it executed. There's nothing bureaucratic about what happens next. The lead Seahawk doesn't head for the target vessel. It sweeps past and takes up position on the far side. The door gunner swings the GAU-21 toward the boat. This is a .50 caliber machine gun capable of turning fiberglass and aluminum into confetti. The gunner isn't going to fire yet, but the message is clear. Run, and this becomes a very short conversation. The second helicopter moves into position directly over the target's deck. The crew chief kicks out a thick rope. Then the SEALs start sliding down. Fast rope insertion is exactly what it sounds like. Operators grab a rope and slide down wearing nothing but gloves and body armor. No harness, no safety line, just grip strength and controlled falling. A 4-man team can hit the deck in under 8 seconds. By the time the boat's crew processes what's happening, there are already armed men on top of them. Cooperation looks like hands up, face down, zip ties, and a thorough search of the vessel. The SEALs move through counterparts with practiced efficiency. They're looking for weapons, contraband, intelligence materials. The whole evolution takes maybe 15 minutes. Resistance looks different. The moment that someone on that boat produces a weapon, the rules change. The door gunner on the orbiting Seahawk opens up with the GAU-21. At 1,100 rounds per minute, the gun doesn't fire so much as roar, a continuous thunder that tears through the vessel's superstructure like it's made of paper. The SEALs on deck return fire with precision. The engagement is over before it really begins. But here's where it gets interesting. What if the boat's crew brought something bigger than small arms? MANPADS, Manned Portable Air Defense System, are shoulder-fired missiles designed to swat helicopters. They're cheap, widely available, and scattered across every conflict zone on the planet. Anyone with $50,000 and the right contacts can get their hands on one. Point it at a helicopter, wait for the secret tone, and pull the trigger. During the demonstration, the Seahawk showed exactly what happens when someone tries this. The missile comes off the rail trailing smoke. The helicopter's defense systems are already reacting. Flares eject in a programmed pattern. White-hot decoys burning at temperatures designed to overwhelm the missile's infrared seeker. The aircraft banks hard, putting distance and angle between itself and the threat. The missile's guidance system sees multiple heat sources, can't distinguish the real target from the decoys, and loses lock. Meanwhile, the door gunner is solving the problem at its source. The GAU-21 swings toward the launch point. The person who fired that MANPAD has about 3 seconds to reconsider their life choices before the .50 caliber rounds start arriving. This is the final layer of the Carrier Strike Group's defensive measures. Not missiles, not aircraft, not guns. Men with rifles standing on the deck of a hostile vessel, sorting out the threats at bad breath distance. But what is wilder about what they just showed Trump is not just the capabilities, but how little was actually demonstrated. Right now, at any given moment, at least 4 carrier strike groups just like this one are forward deployed across the globe, in the Western Pacific, the Mediterranean, the Middle East, and the Atlantic. Each one carries the same capabilities that you just saw. Within 48 hours of a crisis anywhere on Earth, a carrier strike group can be on station. No negotiations, no permission required, just 5,000 sailors, 70 aircraft, and enough firepower to dismantle a small country arriving faster than Amazon Prime could deliver. Bye for now.